In today's lesson, we're going to be looking at systems of inequalities in terms of word problems. So let's do a couple of examples together. Number 1 says, suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Ooh, that makes me hungry. Flour costs $1.50 per pound and cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need it, but you need at least 6 pounds altogether. Write and graph a system of linear inequalities. So what we're going to do is create a graph that will find all the possible combinations of flour and cornmeal that we can afford that will meet our needs of at least 6 pounds of flour and cornmeal. You will notice that the first sentence is about money. Now, one of the things that we did not do, which we certainly should have, is define X and Y. What we've actually done is defined X and Y by labeling our graph. Notice that flour is written along the x-axis. Please pause and write flour along the x-axis right here at the bottom. And write cornmeal along the y-axis. So this will be a way for us to define X and Y. X is flour, Y is cornmeal. Now we write our equations. The first equation is about money. $1.50 times the pounds of flour plus $2.50 times the pounds of cornmeal needs to be less than or equal to 25 because we want to spend, it says less than $25. So really, I probably should just have a less than and not a less than or equal to. The rest of the sentence says that we need at least 6 pounds altogether. So the pounds of flour, X, plus the pounds of cornmeal, Y, should be greater than or equal to 6. Notice that we have solved each of the equations for Y so that they are in slope-intercept form to help us graph. The first equation has a y-intercept of 10, so we began there, and a slope of negative 3/5, so we move down 3 over 5, down 3 over 5, down 3 over 5, and this top line represents that. Now less than means we'll be shading below that. The second equation has a y-intercept of 6, so that's this lower line, and a slope of negative 1. So down 1, right 1, down 1, right 1, and continuing on. But we need to shade above this one. So the shading that you see here is only where the two shadings intersect because we're shading below the upper line, above the lower line. So this region that you see shaded here is where the two shadings intersect. It's fine if you went ahead and shaded completely below the first line and completely above the second line. Just make sure that it's very clear where the two shadings intersect. And that's why using two different colors to shade your graph could be useful. This region represents all the points that would create a possible solution to our problem. So here it says write two possible solutions. There are a lot of possible solutions in this region. I'm not going to say infinitely many because this is a bounded region and we're probably only going to buy integer pounds. Like we're not going to buy 1.78 pounds. We'll buy 1 pound or 2 pounds. So there are a limited number of answers, but still a lot of them. When it says write two possible solutions, you have lots of choices. This first solution says 6 pounds of flour and 2 pounds of cornmeal. Remember that X is flour and Y is cornmeal. This is from the point 6, 2. If you start at the origin and go to the right 1, 2, 3, 4, 5, 6, and up to 1, 2, you will find the point 6, 2 is in the shaded region. And that's why 6 pounds of flour and 2 pounds of cornmeal would satisfy our problem. That would allow us to spend less than $25, and it would allow us to have at least 6 pounds of flour and cornmeal. The second possible solution, 8 pounds of flour and 4 pounds of cornmeal, is represented by the point 8, 4. So if I move over to an X value of 8 and up to a Y value of 4 from the previous point, I'm still in the shaded region. So again, that second possible solution works because it's in the shaded region. You could have selected many other possible solutions that would have satisfied this situation. Let's look at one more together. A seafood restaurant owner orders perch and salmon. Perch is $4 per pound and salmon is $3 per pound. He wants to buy at least 50 pounds of fish, but cannot spend more than $240. So let's write our equation. The first equation is about money. Let's label our X and Y axis so we know what X and Y represent. The two things that we're looking for are pounds of perch and pounds of salmon, two different types of fish. We've chosen to let X represent perch, and we've labeled the X-axis as perch. We've chosen to allow the Y-axis to represent pounds of salmon. I want you to notice that we're only using one quadrant graphs in this activity because we're not concerned with negative answers in this situation. You're not going to go buy a negative amount of flour or cornmeal or fish. We're only concerned with positive values here. So in these situations, it's completely appropriate to use just a graph with the first quadrant. Negative answers simply don't make sense in our situation. All right, so $4 per pound of perch, 4X, plus $3 per pound of salmon, 3Y, and we cannot spend more than $240, so we need to spend less than or equal to $240. If you rearrange that into slope-intercept form, we have that version here. The second equation is about the pounds of fish that we need. The pounds of perch, X, plus the pounds of salmon, Y, needs to be at least 50, greater than or equal to 50. And so we have that changed into slope-intercept form for graphing. Now, these numbers 80 and 50 do not work for our graph because it doesn't go up to 50 and 80. But I think we must be counting by tens. Let's see. If we start with 0, this would be 10, 20, 30, 40, 50, 60, 70, 80. So we're clearly counting by tens along our y-axis and our x-axis as well. So we're counting by tens. So the first line has a y-intercept of 80. So you go up 10, 20, 30, 40, 50, 60, 70, 80. This top point is at 80 along the y-axis. And as long as your x and y-axis axes are scaled the same, in this case by tens, then you don't really need to worry about that when you're doing the slope. You can still just go down 4 over 3, down 4 over 3. So then we draw the line, and again, it's less than, so we would shade below the top line. In the second line, the y-intercept is 50, 10, 20, 30, 40, 50. The slope is -1, down 1 over 1, and so on. And we're shading above that line. So if you shade below the top line and above the bottom line, the two shadings will intersect in this skinny little region here. So while there are many correct answers, there's not a whole lot of them to choose from. But what we want to do is select two possible solutions. Now, you have to keep in mind that we are scaling by tens. So the first point that I have selected is 10, 50. So if you move to the right, 10, that's just one space, and then up 50, 10, 20, 30, 40, 50, you will find that that point is within the shaded region. We call that the feasible region. It means that every combination in that region is feasible or doable in our situation. So if we buy 10 pounds of perch and 50 pounds of salmon, it will satisfy our requirements. That will make sure that we have at least 50 pounds of fish, but we will not be spending more than $240. Another point is 30, 30. So if you start at the origin and count by tens, 10, 20, 30, and then up 10, 20, 30, you'll find once again a point within the feasible region. So if we buy 30 pounds of perch and 30 pounds of salmon, then we will be good to go. We will have at least 50 pounds of fish, and we will have spent no more than $240. If you want, pause the video and give number 3 a try. Let's see how you did. In this example, We Sell CD's website plans to purchase ads in a local newspaper to advertise their site. Their operating budget will allow them to spend at most $3,000 on this advertising adventure. An ad will cost $30 to appear in the weekend newspaper and $50 to appear in the weekend edition. I think I said that wrong. To appear in the weekday paper and $50 to appear in the weekend. More people read the newspaper on the weekend, so they'll get more readers to see their ad on the weekend. That's why it costs more. They plan to run at least 20 ads. All right, so we're going to let X be the number of weekday ads and Y the number of weekend ads. The first equation that we write is about money. So we're going to have $30 times the number of weekday plus $50 times the number of weekend, and that's less than or equal to $3,000. We also need at least 20 ads, so X plus Y is greater than or equal to 20. We put these in slope-intercept form and graph, and then again simply select 2 points within the feasible region. Once again, it's appropriate to scale by tens. I hope this helps. Good luck, everyone.